Hey class, I'll be making a series of videos to help us review old topics and prepare for the upcoming AP exam. This year is weird. It's going to be taken at home. AP exam is going to be 45 minutes, 2 questions total, and both of those questions are going to be free response. So more on that later this week. Today I want to talk about SOCS and outliers. You may remember way back when the very first acronym we learned was SOCS, but misspelled because Miss Dang can't spell. So here's what SOCS stands for. You use SOCS anytime you are asked to describe a distribution. If it says describe a distribution, use SOCS. All right, so let's review that really quick. The first S stands for shape. Here are your options. We got approximately normal. Now, I'd stay away from saying this distribution is normal, because is anything ever actually normal? Approximately makes it a lot safer. So approximately normal, maybe it's skewed left or skewed right. And then something I'm going to talk about later, bimodal, which we've discussed, but last year this was on number 1 of the free response, and everyone was like, what's that word? So we're talking about it here. Outliers is the O, and that includes unusual features. And when I say unusual features, the first thing I think of is maybe there's a gap in your data. So I'll show you what that looks like later. And then stay tuned over here. We're going to do the outlier formula. Okay, the C stands for center. It's going to be the mean or the median. You don't have to describe both. Feel free. But I usually just stick with one. Now, something to know about mean and median is that the mean, it is not resistant to extreme values. So if there is a really low outlier, that's going to pull the mean down. If there's a really high outlier, it's going to pull the mean up. The median is more resistant than the mean to those outliers or extreme values. So if you have a skewed distribution, and there's some sort of question that says, what's a better measure of center? Well, if it's skewed, you should probably use the median because that's resistant. The mean is good anytime the shape is approximately normal. Or bimodal, sure, that works too. And then for spread, variability. So the reason why I put variability down here is that they kind of mean the same thing. I use the word spread because I wanted it to spell SOCS. Sorry. But on your AP exam, you might see variability. That just means spread. Here are your options. You got standard deviation, range, IQR, which is the interquartile range, and variance. I usually stick with these 3. What is variance? You might remember that the standard deviation squared is the variance. So that's what variance is the standard deviation squared. You probably see that on your formula sheet like this. Remember when we're doing confidence intervals and hypothesis tests? It's sigma squared. That's the standard deviation. All right, fantastic. Let's move on. Outlier formula. I wrote it for you here, and I highlighted the only differences. For the low outlier, you'll see Q1 and it's minus. Then over here we got Q3 and it's plus, because you're looking for the low outliers right here on the low end and then on the high end here. So after you calculate whatever value this is for the low outliers, if your value is lower than if your minimum value is lower than this value right here that you find, lower than this, that is an outlier. Same logic goes here. If your maximum value is higher than this, whatever value you find, then that's an outlier. So what I'm going to do now is I'm going to go through a couple examples that came from sorry, there's a hair on my iPad. That came from actual AP exams in the past. I can't promise you that the FRQs this year are going to look exactly like these. What I think is going to happen is that the free response this year since there's only 2, they're going to have way more parts, like part A, part B, part C. They're going to have way more parts than we're used to, is my hunch. Okay, so this example right here, SOCS, this is actually from 2016, number 1. So if you want, just type in AP Stats 2016 for your response, and then you can Google and find the answer and the scoring guide for this one. So let's go through this one together. Robin works as a server in a small restaurant where she can earn a tip, extra money, from each customer she serves. The histogram below shows a distribution of her 60, sorry, I can't help it, but I start annotating 60 tip amounts. So the sample size there is 60 for 1 day of work. Part A, write a few sentences to describe the distribution of tip amounts for the day shown. Describe the distribution right there. Okay, as soon as you see that, what does that mean we have to do? We gotta do SOCS. Okay. I'm just going to list out the parts of SOCS that I need. I usually do that. And one thing I want to tell you guys is, yes, you need SOCS, but if you do not include context, you're going to lose a point there and not get that essentially correct when you should have. So you need SOCS and at least context in one of these things, I think just once. So what I'm going to do is I'm going to do the context straight away in the shape. So we're going to come back to that. So shape, outliers, center, spread. Okay, I'm going to show you my thinking here. So I want to get context out of the way so I don't have to worry about it. So I usually do context for the very first thing I do, which is shape. So let's look at the shape of this distribution. It is skewed, and then think about your foot. Your big toe is usually over here, and your little toes are over here. So that's your right foot. So this is going to be skewed right. So I'm going to take the context. Let me see. Distribution over 60 tip amounts from 1 day of work. Okay, that's my context right there. So I'm going to say the distribution of, what's her name? Robin, 60 tip amounts is skewed right, like my right foot. Okay, I got the context out of the way, so I don't have to worry about that anymore. Outliers. So I'm looking at this histogram. I actually can't tell the exact tip amounts because it's a histogram. It just gives me like a range here. And any range that falls between, for instance, if this is 5, then this is 250. The number of tips between 0 and 250 is 25, but I don't know what those exact tip amounts for the 25 are. So I can't actually calculate outliers here, but I can probably guess from looking at the distribution. We see this tip over here that's really far away from everyone else. So I'm going to say there appears to be an outlier. Now, if you tell me, hey, there's an outlier, I don't know. Like, I can't really give you the credit there. You got to tell me where that outlier is. So this outlier, I can say, is greater than 20. So if you can give me that, that gives me a little bit more information there. Appears to be an outlier greater than 20. Now, adding that $20, the dollar sign for the correct context there. Okay, instead of outliers, you could have also said that there was a gap between 15 and 20. That would give you credit for unusual features / outliers as well. But I'm just going to stick with outliers because that's what I'm comfortable with. All right. Center. You could find both the mean and the median here. Up to you which one you want to do. I usually lean towards the median. So here's how you're going to find the median. Well, we said that there were 60 data points. So what data point is the middle? Here's a little trick you can do. Median is going to be the smallest number of that data point. Well, I might not be explaining this correctly, but there's 60 numbers, 1 through 60. Those are not the tip amounts. I'm just saying there's 60 numbers. So the median is going to be the lower number plus the top number divided by 2. What I'm doing is I'm taking the average of the lowest number and the highest number. So that would be 61 divided by 2, which gives me 30.5. When you get a number that is a 0.5 like that, that means that the median is between the 30th value and the 31st value. If you had gotten a whole number, let's do something easy, like if there were only 3 numbers, we know the median's 2. But you would do 1 plus 3 is 4, divided by 2. That means the second number is the median. So it doesn't really matter if you're not sure. We know that the median's around the 30th term from 30.5. So I'm going to go back over here. So there's 25 right here. So that the 30th is going to fall, well, it's going to fall in this one because 25 plus 22 is greater than 30. So I know that the median is going to be between 250 and 5. So I'll say that right here. Median is between, wow, sorry, terrible handwriting today, $2.50 and $5. It's okay that we're not exact. This is statistics. If we can be exact, great. If not, give me a range. Speaking of range, spread. Let's do the range for this one because I'm not about to estimate the standard deviation here. It's a little bit too hard. So the range is the biggest number minus the smallest number. So this point right here is 2250. Well, 2250 minus 0 is just 2250. So I'm going to say the range is about 2250. I'm going to say about because do I know that this one tip amount was that actually 2250? I don't know that, and I don't know if the lowest amount is 0. You could have all of these 25 be like $2, and the histogram is still true. So that's why I like to say the word about. 2250, and just so that you guys remember, 2250 minus 0 is how I got that range. That's it. There we go. We described the distribution and we included context. I'm not going to go through the full question here on this one. I just wanted to talk about it really quick. So this was last year, 2019. Number 1, you'll notice that they asked you to describe the distribution here as well. And this is what I want to throw in. The shape of this, it is not approximately normal. In fact, it is not skewed. It's kind of it's symmetric. I would say approximately symmetric. But the word I'd recommend you using, because this was the word that we're looking for that year, it's got 2 humps. So this shape is bimodal. I doubt it will show up again this year after showing up last year, but you never know. So that just brings us up to the different shapes. You can have approximately normal, symmetric is included in there, skewed left, right, and bimodal. Unimodal would be 1 hump, aka symmetric or approximately normal. All right, last one. This is actually a continuation of this question up here. It was part B, is where they asked you to calculate outliers last year, and a lot of AP Stats students were able to do this, and I was super happy with that. So I'm going to highlight the statistics that are the most important to me here. Q1 and Q3. So let's go ahead and do this. I'm going to write out the formulas first. This is for the low outliers, and then the high Q3 plus 1.5 IQR. Okay, and let's just plug everything in. Well, I want to find the IQR, which is just Q3 minus Q1, so let's go ahead and do that first. Going to pull up my graphing calculator here. This is Graphing Calc 83. It is currently free if you have an iPhone. I recommend it for your AP exam if you don't have your actual graphing calculator. All right, 118. Okay. So Q1 for the low outlier is going to be 174 minus 1.5 times 118. Q3 down here is 292 plus 1.5 times 118. Okay, I want to find those values. -3. Okay, and then let's just go ahead and do the other one. Being lazy, so I'm just typing over it. 469. All right, so now let's figure out if we have outliers or not. So now we gotta look at the minimum and the maximum. Okay, the minimum's 134. Well, anything lower than -3 would be an outlier. So in this case, there's no low outliers. No low outliers. Would have to be like a like -4 would be an outlier. All right, maximum 315. Okay, is the maximum. And if anything higher than this would be an outlier. Well, 315 is lower than that. So there's no high outliers either. Okay, fantastic. Question from last year when we went over this. Hey, would you get credit if you just say there's no outliers? No, because you could just guess that. Just make sure you show your work and you'll get your credit. Okay, I think that was it. Miss you guys. Bye.